What's up, Algebra 1 students? This is lesson 39, and our objective is how do you use the distributive property with rational expressions? Well, before we get into rational expressions a little bit, let's just recall how to use a distributive property. Or with the distributive property, you can think of hippity-hoppity if you want, hippity-hoppity distributive property. This one on the outside gets multiplied by each one. This is going to be 3x times 4xy plus, it just comes down there, 3x times 2. 3x times 2. You don't necessarily have to write that step. Now if you can multiply them in your head, this would come out to be 12x squared y plus 6x, and that would be my answer. Okay, now we're going to do the same thing, except for now we're going to be working with rational expressions. And something we have to realize on rational expressions is that my denominator, when there's letters in there, that those denominators can't equal 0. So whenever we're finished working out and simplifying this problem, we're going to need to make sure and define that any variables on the bottom don't equal 0. Otherwise, my whole expression would be undefined. So let's go ahead and try this distributive property idea here. This times this. So it's going to be a over b cubed times a squared over b plus a over b cubed times 3b squared over z. Okay, I've just set that into each of those. Now, of course, we don't want to leave it like that. We want to simplify as much as we can. This first term here, a times a squared, is going to give me a cubed. B cubed times b is going to give me b to the 4th. Plus, over here, I have some b's on the top and b's on the bottom. I have 2 of them on top and 3 of them on the bottom. So I'll end up with just 1 b on the bottom, and also the z. And on top, I still have a 3 and an a left over. Now I'm going to look at the bottom, and I'm noticing there's 3 different variables. Well, just kidding, there's 2. There's a b in both of them, and there's also a z. So what I'm going to do is I'm going to say b cannot equal 0, and z not equal to 0. Otherwise, this whole expression here would be undefined. Okay, so that'll be my answer there for the first one. Thus, these next two are pretty similar, same concept, except now we're dealing with negative exponents as well. And we'll kind of work with those as we go, but you'll recall that negative exponents just means that they're on the wrong side of the division bar, and we gotta have to pull them across and change their sign with those. So let's try one here. This times this, x squared times x squared is going to give me x to the 4th. And then my denominators is going to be y to the negative 3 times y to the 1st power. So this is going to be y to the negative 2. Minus this one on the outside times this one. So we're going to have a 3, I'm looking at the numerators, x squared, and a y and a z to the negative 2. The denominator, I'm going to have y to the negative 3 and an x. Okay, now we want to write our answer with only positive exponents and then reducing things from top and bottom. So I'm noticing on the second term here, there's 2 x's up there and 1 x down here, so that reduces to just giving me exponent of 1. This z to the negative 2 is going to need to come down to the bottom, which would make it a z squared. And then this y to the negative 3 on the bottom would need to come up to the top, making it a y cubed, and then remember there's also a y there. And then this y is going to need to come up as well, making it a y squared. So to simplify here, I'm going to have x to the 4th, that's what was there already, and then a y squared, that's the one from the bottom, minus, I still have this 3, I have the y cubed and the y to the first power, which is going to give me y to the fourth. And then this is going to be over z squared. And that's going to be my answer right here. Except, what's in my denominator? Z. So z cannot equal to 0. Don't forget that. If you have any letters in the denominator, you have to specify that those cannot equal 0. Remember, my denominator over here would just be like 1, right? So 1 can equal 0, so we're good with that. Alright, let's try this next one. This one times this one. This is going to give me a to the negative 1, there's a 3, bm, and then I'm just writing these in alphabetical order. A to the negative 2, b squared, c to the negative 4, d, plus this one times this one. This is going to be a to the negative 4, because I added that negative 1 and that negative 3. And then c to the negative 4 over b squared. Now let's see here. This a I'm going to bring up at the top. These b's will reduce. There's 1 there and 2 there. And that c I need to bring up top. This a I need to bring down, and this c I need to bring down. So that's going to give us 3. Notice I'd have an a squared from this one right here, and then an a minus 1, so it's going to just give me an a. No more b's. I'm going to have c to the 4th and an m. On the denominator, I'm going to have a b and a d. Plus, well, I've pulled everything off the top, so I'm just going to have a 1 there because I don't want to leave it blank. I'm going to have a to the 4th, b squared, c to the 4th. And then a can't equal 1. Sorry, can't equal 0. B can't equal 0. C can't equal 0. And D can't equal 0. One more example here before I turn you loose on homework, and this is just one that has 3 terms in it. Still the same principle, except for I'm going to send it into each one of those. It's going to be hippity, hoppity, I don't know, hoopity, whatever you want to think about for that. So let's do that. So we have an m to the first power times m to the negative 2 is just going to give me m to the negative 1. And then n to the negative 4 times n to the first is going to give me n to the negative 3. And then I have an r from right there. My denominator is going to be p to the negative 2 times p cubed, which is just going to give me p, because remember you just add those exponents. Minus, well, I'm going to have an m, and then double here, n to the negative 4 times n to the 4th. Add exponents is going to be n to the 0th, which is just equal to 1. So you're going to think of this times 1. And then we have an r squared. On the denominator we have that p to the negative 2. Plus 8 m squareds, n to the negative 4 over p negative 2, and this is an exponent of 1, so it's going to be to the negative 1. Now let's see if we can move stuff around like we need to. This m needs to come down, this n needs to come down, this p needs to come up, this p needs to come up, This n needs to come down. So then, on the top of this first one, I'm just going to have an r. On the denominator, I'm going to have m n cubed p minus, this is going to give me, I don't need to write the 1 there, so it's just going to be m r squared p squared plus 8m squared p over n to the 4th. So m cannot equal to 0, n cannot equal to 0, and p cannot equal to 0, because all three of these, m, n, and p, and n, those are all in the denominator. So this would be my answer. Good luck. Your homework is on page 246. You can do all of the 39s, all the 38s, and then 10 more of your choice. Good luck, guys.